In this video, I'll demonstrate how to manually calibrate the automatic control box or do advanced programming of the auto control box after calibration has been completed. To begin programming of the auto control box, you will need to be in manual mode. You will see the manual indicator at the lower right of the controller's display. If the controller is in auto mode, the controller display will show auto at the lower right. You can switch to manual mode by pushing the orange mode button once. The controller will now show manual on the display. Before beginning the advanced programming, you will need to check the supply voltage and normal running amps of the pump. Let's begin by pushing the green start button once. The pump will start and the controller will flash the run indicator on the bottom left of the display. The voltage will be displayed on the left of the controller's display and the running amps will be displayed on the right. Make sure that water is running into the tank to ensure the pump is pumping to its total head height. Then make a note of the running amps. In my case, the running amps are 4.1 amps. Now we can stop the pump by pressing the red stop button. The amps on the right of the display will drop to 0 amps. If the calibration has not been done, no cal will flash on the bottom left of the controller. But if the controller has been previously calibrated, then the no cal indicator will not be displayed. To enter the advanced programming menu, we'll push and hold the orange menu button for about 6 seconds. You'll hear a beep and the display will change. We can now release the mode button. The controller display will show the function 001 on the left and the lower middle of the display will show the DR or dry run indicator. The upper right of the display will show the dry run time, currently set to 6 seconds. This means that if the pump's current falls to the preset dry run amps value for 6 seconds or more, the pump will be switched off by the dry run protection function. 6 seconds is normally a good setting, but you can change this time to be longer by pushing the green start button. Or you can lower the time to increase sensitivity by pushing the red stop button. If there are no special conditions with your pump setup, you can leave this dry run time set to 6 seconds. To enter function 002, we'll push the orange mode button once. Function 002 is the time that the controller will wait after detecting a dry run before starting the pump again. It is set to 30 minutes by default, but this time can be increased to up to 250 minutes by pressing the green start button. The dry run wait time can be decreased by pressing the red stop button. We like to set the dry run wait time to at least 60 minutes to give the borehole time replenish in the event of a dry run. To enter function 003, we'll push the orange mode button once. Function 003 is a current at which the controller realizes a dry run condition. My controller, which is a 0.37 kW control box, has its dry run amp set to 2.3 amps. Before beginning the programming, we determined that our normal running current was 4.1 amps. Your pump's normal running amps may differ, depending on the size of the pump and the total head height that it is pumping. We have found the best setting for the dry run current to be 15% lower than the normal running current. We can calculate this by dividing the normal running amps x 1.15, and that gives us 3.56 amps. We'll round that up to 3.6 amps. We can now set the dry run current up to 3.6 amps by pushing the green start button. To lower the dry run current setting, press the red stop button. If you have a higher kilowatt pump and your normal running current is higher, the process remains the same. Take your normal running current and divide it by 1.15 to get your dry run current setting. To enter function 004, we'll push the orange mode button once. Function 004 is the overload current setting. The factory calibration sets the overload current to roughly 35% higher than the normal running current. If you are manually setting up the control box, you can multiply your running current by 1.35. So 4.1 amps multiplied by 1.35 will give us 5.53 amps. We can round that down to 5.5 amps. We can now go ahead and increase the overload current setting to 5.5 amps by pushing the green start button. Or we can reduce the overload current by pressing the red stop button. If you have a higher kilowatt pump and your normal running current is higher, the process remains the same. Take your normal running current and multiply it by 1.65 to get your stalled current setting. To enter function 005, we'll push the orange mode button once. Function 005 is the stalled current setting to protect the motor in the case where the pump end is suddenly jammed, and it prevents the motor from rotating. The factory calibration sets the stalled current to roughly 65% higher than the normal running current. If you are manually setting up the control box, you can multiply your normal running current by 1.65. So 4.1 amps multiplied by 1.65 will give us 6.76 amps, and we can round that down to 6.7 amps. We can now go ahead and increase the stalled current setting to 6.7 amps by pushing the green start button. Or we can reduce the stalled current to 6.7 amps by pressing the red stop button. If you have a higher kilowatt pump and your normal running current is higher, the process remains the same. Take your normal running current and multiply it by 1.65 to get your stalled current setting. To enter function 006, we'll push the orange mode button once. Function 006 is the under voltage setting to protect the motor in the case where supply voltage drops below a certain threshold. Before beginning the advanced programming, we noted that the voltage was between 237 and 242 volts. Normal input voltage in South Africa is between 220 volts and 250 volts. So let's calculate our undervoltage as 10% less than the normal supply voltage of 220 volts. We take 220 volts divided by 1.1. That gives us 200 volts. We can set our undervoltage up to 200 volts by pressing the green start button. And if we need to decrease the undervoltage setting, then we can simply push the red stop button. The undervoltage setting of all 220 volt pumps will be the same. If your area is lower than normal voltage, you can slightly reduce the undervoltage setting to around 195 volts. To enter function 007, we'll push the orange mode button once. Function 007 is the overvoltage setting to protect the motor in the case where the supply voltage increases above a certain threshold. Before beginning the advanced programming, we noted that the voltage was between 237 volts and 242 volts. Normal input voltage in South Africa is around 220 volts, so let's calculate our overvoltage as 10% higher than the normal supply voltage of 220 volts. We take 220V multiplied by 1.1. That gives us 242 volts. We can set our overvoltage down to 242V by pressing the red stop button. And if we need to increase the overvoltage setting, then we can simply push the green start button. The overvoltage setting of all 220 volt pumps will be the same. But if your area has higher than normal voltage, you can slightly increase the overvoltage setting to around 250 to 255 volts if needed. Programming of the auto control box is now complete. To return to the main controller screen, press and hold the orange mode button in. For about 3 seconds, you will hear a beep and the left side of the display will again display the input voltage.